Hi, this is Mrs. Blake, and today we're going to talk about solution stoichiometry. Before we talk about solution stoichiometry, let's just do a real quick review of what stoichiometry is and how stoichiometry works. So stoichiometry is about taking moles of some substance in a balanced equation and using it to find moles of something else. So the key material you need to be able to do stoichiometry is moles. And we use that, what we refer to as the mole ratio, from that balanced equation as the process of doing stoichiometry. So most chemistry classes are going to start with solid stoichiometry, and you start with some mass that's going to be measured in grams. But you can't do stoichiometry without getting it to moles, so you used a molar mass to get it to moles of something else. And then at the end, if you're measuring data in lab, you need it back to another mass in grams and use the molar mass of whatever you are going to be able to figure that out. But stoichiometry is not grams to grams. Stoichiometry is moles to moles using a balanced equation. And anything you use to be able to get to moles, you can use for stoichiometry. So we're talking about solutions, and you would not measure solution in grams because grams of water and grams of solute cause a problem. So frequently solutions are going to be measured in milliliters or liters, and it does have to be in liters, so you may need to convert a number. And can I get 2 moles from liters? And yes, this is a solution. There's also liters of a gas, which would be a different process. And yes, I can use my molarity. There is a difference here. A molar mass that I am using as a conversion factor is not a number that's generally given to you because they're going to expect that you can add it up from the periodic table. But if I am using the molarity as a conversion factor, this is a number that has to be given. And it means that this problem would have 2 numbers to start instead of just the one. Now, at the end of the problem, if I'm measuring a solution, then I may also have to go back to liters of a solution. And if I go back to liters of a solution, I would need another piece of information. I would need the molarity. So they're going to have to give you more information in a solution stoichiometry problem. So let's take a look at a couple of things, and then let's take a look at a couple of problems. First of all, a reminder that molarity is going to be the number of moles in 1 liter of solution. And this unit becomes much more usable than the capital M. So in my problems, I am always going to change a capital M to some number of moles per 1 liter. The second thing is that you are never going to start with molarity. So let's take a look at a couple of problems. So what volume of 0.415 silver nitrate will be required to precipitate as silver bromide if all of bromide ions in 35 milliliters of 0.128 calcium bromide? Okay, so more information. First of all, the question is asking me to find a volume of silver nitrate. And so I'm just going to go to silver nitrate, and I am going to look for some volume. That's going to be in liters. And they are going to give me 0.415. Notice I'm changing it to moles per 1 liter of of solution. And what are they going to give me? Well, they're going to give me 35 milliliters of 0.128 molar calcium bromide. Anytime I use molarity, I have to use liters. So I'm going to automatically change this to liters. And I know that my molarity is 0.128 moles per liter. Well, I'm going to start with what they give me 2 pieces of information of. And since I never start with the molarity, I'm going to start with the volume. And I know I have 0.0350 liters of calcium bromide. And that means that when I'm setting this up, I'm going to have to put liters of calcium bromide on the bottom because I want to get rid of it and change it to something else. So I'm going to start with my volume, and I am going to use my molarity to get me to moles. And if I set my problem up this way, this unit goes down here, I know that it's going to be some number of moles of calcium bromide in 1 liter of calcium bromide. And the problem gives me that it's going to be 0.128 moles of calcium bromide per 1 liter of calcium bromide. Well, that gets rid of my liters of calcium bromide and leaves me with moles. And once I get to moles, now I can use my balanced equation for stoichiometry. The key part of stoichiometry is going to be that mole ratio. That is going to allow me to be able to get from calcium bromide to silver nitrate. So I know this unit comes down, so I'm going to have moles of calcium bromide that comes on the bottom. It is a mole ratio, so moles goes on top, and whatever I'm going to, and this is going to be silver nitrate. And these numbers come from my balanced equation. So there's no number in front of my calcium bromide, but there's a 2 in front of my calcium, or my silver nitrate. That's going to get rid of calcium bromide for good, and now I'm left with moles of silver nitrate. I could, in theory, go to grams from here, but this problem wants me to find the volume, and it gives me a new molarity. So when I'm taking a look, how do I use that molarity? Well, I'm going to follow my problem and know that moles of silver nitrate needs to go on the bottom because I want to get rid of it. And if I'm using a molarity, it is moles per liter of silver nitrate. Technically, it's moles per 1 liter of silver nitrate. And that molarity then is going to allow me to be able to get to 2 liters of my solution. So I have 0.415 moles per liter, and I can plug that number in. In a calculation like this, anything on top is times, anything on the bottom is divided by, and the order doesn't really matter. And I'm going to punch those numbers into my calculator, and I am going to come out with 0.0216 liters of the silver nitrate. Sometimes you will be asked to change it into milliliters. In this problem, it just tells me to find the volume, so I can leave it just the way it is. So in the second problem, we're going to have some differences. Second problem, I am going to be asked to find the mass of silver bromide precipitate. So in a chemical reaction, if it ends up as a solid, I've got to measure it in grams. And this is going to start with 25.5 milliliters of 0.128 molar calcium bromide. And they tell me that silver nitrate's in excess, so I don't really need to worry about that number. So again, I need to take and start with my volume. But my volume has to be in liters. So I'm going to start with 0.0255 liters of this calcium bromide. And if I start with volume and I set up my problem, I know volume is going to go on the bottom so it can cancel out. And they're going to give me a molarity that is going to allow me to switch it to moles. So if liters is on the bottom for molarity, moles goes on top. And the problem tells me that it is going to be 0.128 moles per 1 liter of solution. And that allows liters to cancel, top and bottom, and it leaves me with moles, so that now I can use my mole ratio. So every stoichiometry problem you will ever do, you're going to use a balanced equation and a mole ratio, and it is going to take you from moles to moles. And in this problem, it's going to be moles of calcium bromide goes on the bottom because I want to get rid of it. And it is going to take me 2 moles of what I'm ending with. And in this problem, I'm going to end with silver bromide. And it tells me that there is no number, which is 1 in front of my calcium bromide, but there is a 2 in front of my silver bromide. And that gets rid of my moles of calcium bromide for good. And now that I'm at moles of silver bromide, if this was a solution, I could turn it into liters. But this isn't a solution. This is a solid. And so I'm going to need a molar mass to turn it back into grams. And so moles of silver bromide is going to go on the bottom. And I'm turning that into grams of silver bromide. And molar mass says in 1 mole of anything. And silver is 107.87 and bromine 79.90. And I add those together and I'm going to come up with 187.77 grams. So my moles of silver bromide cancels out. And that leaves me with the grams that I'm looking for, the mass in grams that I'm looking for. So I'm going to multiply across the top and I am going to divide by the bottom. And I am going to come out with 1.23 grams of silver bromide, which would be the mass of my precipitate. So let's take a look at one more problem. And this one, I am not going to start with a solution. And this time, I'm given a number of a mass in grams. And I'm supposed to use that to find out how much of a reactant I'm going to start with. So how many milliliters of 0.415 molar silver nitrate are required to produce 3.50 grams of silver bromide precipitate? So my unknown is with my molarity, and I'm trying to find milliliters of the solution, but this time I'm going to start with grams. Well, if I start with grams, it seems like I'm missing a piece of information until I remember that I have a periodic table that I can use to add up my molar mass. So if I'm trying to turn grams into moles, I'm going to use a molar mass that I can add up and it probably will not be given to me in my problem. So grams goes on the bottom of silver bromide, and I'm going to turn it into moles of silver bromide so I can do stoichiometry. And I know in 1 mole of anything, silver is 108.77 and bromine 79.90, and I can add those up and I'm going to come out with 187.77 grams. So I get rid of grams and I turn it into moles, and then I can use my mole ratio. So moles of silver bromide is going to go on the bottom. It is going to turn it into moles of what I'm going to be looking at, and this is going to be silver nitrate. And according to my equation, I have a 2 in front of my silver bromide, and I have a 2 in front of my silver nitrate. And that's going to get rid of my silver bromide, and I'm going to be left with moles of silver nitrate. Now, once I'm in moles, I could certainly find the number of grams I needed if I was measuring a solid. But in this case, they give me a molarity because they want me to find liters. Again, if you need a molarity in a problem, they have to give it to you. There's no way you can assume what that molarity is going to be. But in this case, moles of silver nitrate needs to go on the bottom so it cancels out. Molarity is moles per liter, and that would put liters on top. And the number they give me in the problem is 0.415 is my number of moles per 1 liter of solution. And that's going to cancel out my silver nitrate moles, and it's going to leave me with liters of silver nitrate. So I multiply across the top, and I divide by the bottom, and I'm going to put this in my calculator, and I'm going to come out with 0.0449 liters of silver nitrate. But if I look carefully my problem doesn't want liters, it wants milliliters. So I'm going to divide by 1,000, or multiply, divide by 1,000. And I'm going to multiply by 1,000, 449. Sorry, 44.9. So with solution stoichiometry, molarity becomes our key to being able to go between liters and moles that I need for